For a change of mood, change to Philips soft-tone pastel light bulbs.
I'm in the mood for love, simply because you're near me. Funny, but when you're near me, I'm in the mood for love.
Make everything seem more beautiful with new soft-tone pastels. It's time to change your bulb to Philips.
If your engine smokes like this and burns oil, it's most likely time for a rebuild. Hi, I'm Scott Cusey, and I'll be your host as we take an inside look at how to rebuild your engine. Rebuilding your engine is a big job. It's time-consuming, and at times it can be difficult. But the rewards you can gain by rebuilding your own engine will more than repay you for your efforts, like saving yourself money, making your car last longer, or increasing the performance of your engine. Not to mention the self-satisfaction that you gain by doing it on your own. The engine we'll be rebuilding was out of a vintage 1967 Mustang. It's a typical V8 style of engine, 390 cubic inches. Although some of the measurements and procedures on the tape were performed on various engines to better illustrate the task. In this tape, I'm going to demonstrate how to restore the original reliability to the engine, but I'll also go one step farther and show the steps necessary to rebuild your engine to better than it was originally. A little extra time and a few extra dollars now can save you a lot of troubles and ensure peak performance and reliability from your rebuild. Because different engines will vary from some of the procedures I demonstrate on this tape, I recommend purchasing an engine rebuild manual or a Haynes manual that pertains to your vehicle or engine. Manuals like these will help you with what to do and when to do it, and also give you the measuring specifications needed to determine the condition of your engine. Now, let's get started with the rebuild. The first section we'll start with is engine removal. Throughout the entire project, you'll need a good basic set of tools, including a good set of wrenches, possibly both metric and American, a 3/8 drive and half drive socket set, a set of screwdrivers and a couple pair of pliers, a couple of drain pans and some floor dry, some masking tape and a marking pencil, some small and medium-sized boxes, and a jack and some jack stands. The specialty items you'll need for this section are an engine chain, a chain hoist or engine puller, possibly a pry bar, and an engine stand. The first step is to remove the hood. We used a set of fender covers over the fenders to protect the finish of our vehicle. Before removing the hood, make sure you mark the location of the hood hinges on the bottom of the hood. This will help you align the hood during reassembly. Next, remove the hood from the car, but get help from another person because hoods can be very awkward and heavy. Before starting engine removal, spray down the engine with engine cleaner and wash it off with a garden hose. This will make it easier to work on and will make cleanup a lot easier once the engine is out of the car. Making sure to start with a cool engine, we started disassembly. First, remove the radiator cap and begin draining the engine coolant. While the coolant is draining, remove the negative battery cable. When all of the coolant is drained, remove the fan assembly, pulley, and belts. We suggest you get some boxes to place small parts and bolts in as you remove them. Label the boxes as to what parts they contain. A few extra minutes now will save you hours during reassembly. Loosen and remove the radiator hoses. Remove the radiator bracket, and remove the radiator from the engine compartment. Remove any other components that will make engine removal easier, like the alternator, the air cleaner, power steering, etc. Before removing any vacuum lines or electrical wires, be sure to label them with a piece of masking tape and a marker. Remove the distributor cap and wires, and label and disconnect any linkages from the carburetor. To protect it from damage during engine removal, we suggest removing the distributor. For ease of connecting the engine chain, we decided to remove the intake manifold while the engine was still in the car. This is usually not necessary for engine removal. To remove the intake manifold, first remove the valve covers. You may need to lightly pry on the valve cover with a screwdriver to break the seal of the gasket. Then remove the intake manifold bolts and remove the push rods. This was necessary for manifold removal on our engine, although it's not necessary on many others. When loosening rocker arm shaft bolts, do so evenly along the length of the shaft and remove the rocker arm shaft assemblies. Next, label and remove the push rods. Lastly, you must break the seal of the intake manifold gasket. An easy way to break the seal is to tap a screwdriver in between the engine block and the manifold and pry upwards. Remove the intake manifold from the engine, but be careful as many factory intake manifolds are very heavy. To prevent self-injury, you may want to use an engine hoist or get help from a friend during removal of the intake manifold. Next, remove the splash pan located in the lifter galley. If your engine has one of these, be careful not to damage it, as it will be reused. For added clearance, we also removed the water pump and the bottom fan pulley. You may need to tap the pulley lightly with a rubber mallet for removal. Next, raise the car with the jack and support it with jack stands. This will give you extra room underneath for disconnecting the motor mounts, the exhaust, and the transmission. On the underside of the car, we first mark the location of the drive shaft to the rear end yoke. This will help assure driveline balance upon reassembly. Then remove the nuts or bolts retaining the rear U-joint. Pry the U-joint from the rear yoke with a large screwdriver or pry bar. The bearing caps of a U-joint have small needle bearings inside them. To prevent the caps from falling off and these bearings from falling out, wrap some tape around the caps of the U-joint. Then slide the drive shaft towards the rear of the car to remove it. Next, label and remove the shifter linkage from the transmission. Loosen and disconnect the transmission end of the speedometer cable. Remove the rear transmission mount bolts from the cross member. Disconnect and remove the clutch linkage. Loosen and remove the bolts attaching the transmission to the bell housing. And slide the transmission straight back to remove it from the car. But be careful, as transmissions are heavy. Use of a floor jack or transmission jack will make the job safer and easier. The next step is to remove the motor mounts. They're usually located on the lower part of the engine on either side. Loosen and remove the bolts connecting the mount to the chassis of the car. You may have to slightly raise the engine to take the pressure off the motor mount bolts for removal. Finish removing any other components, hoses, etc. that may get in the way during removal. The last step for removal is to hook up the engine chain. Attach one side of the chain towards the rear side of the engine, leaving a small amount of free play for the tab. And attach the other side of the engine chain towards the front side of the motor to help balance the weight, and again, leave a little slack for the engine chain tab to move freely. Move the engine hoist into place and connect the hook from the hoist to the engine chain. Raise the engine with the hoist, making sure to watch carefully so you don't damage the engine or the engine compartment. Make sure there is enough clearance between the bottom of the engine and the car when removing the engine. Make any movements with the engine and hoist slowly, as any quick moves could result in damage to the car, engine, or more importantly, yourself. Lower the hoist and allow the engine to rest on a flat surface to steady it while removing the bell housing and flywheel. These items must be removed before you can mount the engine on an engine stand. Remove the starter. The starter must be removed for flywheel removal. Next, if your car is equipped with a standard transmission like ours, remove the bolts attaching the bell housing to the engine, and remove the bell housing from the engine block. With the bell housing removed, begin loosening the bolts on the pressure plate. Loosen them evenly, alternating from one to the other. This will keep the pressure even on the pressure plate during removal. Remove the pressure plate and the clutch disc. With a hammer and punch, mark the location of the flywheel to the crankshaft. This will ensure proper engine balance upon reassembly. One mark on the top and two on the bottom is a good way to mark them. Loosen and remove the flywheel bolts and remove the flywheel from the crankshaft. Although be careful not to drop the flywheel as they are heavy. In our case, we had to remove the flywheel guard cover from the engine block. Then we moved back to the top side of the motor and removed the spark plugs and then loosened the exhaust manifold bolts. We needed to remove the exhaust manifolds from the cylinder heads in order to mount the engine on the engine stand. Again, be careful as exhaust manifolds can be heavy. Now, attach the engine stand mounting head to the engine block. Once the engine stand head assembly is in position on the engine, tighten all the bolts securely. Roll the stand into place, sliding the stand head into position and tighten the lock bolt. Let the pressure down from the hoist and allow the engine to rest on the engine stand. And lastly, remove the engine pulling chain. Now realistically, every engine is going to be a little different than the next one, and some more difficult than others. But generally our example gives you an idea of what's necessary to remove your engine. For specific details on your vehicle, refer to an automotive service manual. Now here's a couple of my own tips to help make the job a bit easier. First and most important, don't be in a hurry. Take your time and the job will go a lot better. You may even save some skin knuckles too. Secondly, the more items you remove while the engine is still in the car, the more room you'll have and the easier it'll be to pull the engine out. If the engine doesn't seem to be coming out very easy, double check for additional bolts you may have missed before just prying on it. If it's a newer vehicle you're working on, you might want to take some pictures during disassembly to refer back to during reassembly. Also, make sure you label all the hoses and electrical connections. A few extra minutes spent now will more than pay for themselves when it comes to reconnecting everything back up. Now let's go on to the next step. This section will cover basic engine disassembly. With the engine on the engine stand, we'll continue with disassembly. This is one of the sections when you need to use a few additional specialty tools. Additional tools you'll need in this section of the tape include a harmonic balancer puller, a rubber mallet, a ball peen hammer and center punch, a 3-jaw gear puller, a needle nose pliers, a 1/2-inch breaker bar, a ridge reamer, and about 6 inches of 3/8 gas line. Of course, some of these tools may vary depending on what type of engine you're rebuilding, but for most V8 or V6 engines, this is all you'll need. Let's take a look at the rest of disassembly. With the engine on the stand, we'll drain the coolant from the block. But to gain access to the block drains, we had to first remove the engine mounts and the engine mount brackets from the side of the engine block. Now remove the small block drain plugs, usually located on the lower side of the engine block. You may need to clean out a little of the corrosion with a screwdriver to allow the block to drain quicker. Make sure to drain the old coolant into a pan and dispose of it properly. Next, we'll remove the harmonic balancer. First, reinstall the large crankshaft pulley bolt in the snout of the crankshaft without the big washer on it. The tool required to remove the harmonic balancer is a harmonic balancer puller. They're relatively inexpensive to rent or purchase. Here's how to use one. First, attach the arms of the puller to the balancer with the bolts supplied with the puller. Remove the balancer by turning the center bolt of the puller clockwise until the balancer is removed from the crankshaft. Now remove the engine oil drain plug and drain the old oil into a drain pan. Dispose of the oil properly when done. A local service station or automotive parts store can recommend a place of disposal. Remove the oil filter and the oil filter housing if so equipped. Remove the timing chain cover bolts. And don't forget to remove the timing cover bolts that go up through the bottom of the oil pan. With all the bolts removed, lightly pry on the timing cover to remove it from the front of the engine. The next step is to remove the timing chain and gears. First, remove the bolt or bolts attaching the cam gear to the cam shaft. In our case, we removed the bolt and the fuel pump eccentric. We then remove the cam gear and the timing chain. It's easiest to remove them both at the same time. Next, we remove the crankshaft gear. On some engines, the crankshaft gear can be removed by sliding it off by hand. Other engines may require the use of a 3-jaw gear puller to to remove the timing gear from the crankshaft. For camshaft removal on our engine, we had to remove a camshaft retaining plate. Once removed, reinstall the cam gear on the camshaft. This will give you extra leverage for camshaft removal and will allow us to turn the camshaft easier for lifter removal. To remove the lifters, turn the camshaft by hand until the first lifter is at its highest point in lifter bore. Then grasp the top of the lifter with your hand or a needle nose pliers and remove it from the lifter bore. Repeat this same procedure on the remaining lifters. With all of the lifters removed, you can remove the camshaft. Grasp the cam gear firmly and begin to slide the camshaft out of the engine slowly. Support the camshaft with your other hand and try to keep it level as you pull it towards you. Take your time and try not to bang the camshaft into the cam bearings. Next, with a breaker bar and socket, break loose all of the cylinder head bolts. We recommend following the head bolt loosening sequence specified in an automotive manual. When all of the head bolts are removed with the exception of one that is still partially threaded in, wrap on each cylinder head with a rubber mallet to break the seal of the cylinder head gaskets. When the seal has been broken, remove the last bolt and lift the cylinder heads from the engine block. Take your time, as cylinder heads can be pretty heavy. Remove the cylinder head gasket from the engine block and discard it. For ease of removal, we turn the engine over to remove the oil pan bolts. But be sure to have a large pan under the engine if you do this, as any remaining oil or coolant will be drained from the engine block. With all of the oil pan bolts removed, break the seal on the oil pan with a screwdriver and remove the pan from the engine. On most engines, you'll see the oil pump, crankshaft, and the bottoms of the connecting rods. Now loosen the oil pump bolts and remove the oil pump from the engine. Some engines have an externally mounted oil pump which can be removed from the outside of the engine. Before removing the connecting rods and pistons from the engine, be sure to mark the bottom of each rod with the corresponding cylinder number to make sure its position in the engine block is not altered during reassembly. An easy way to do this is by using a center punch and staking the bottoms of the rods. Here we show marking the connecting rod bottom of cylinder number 5 with 5 punch marks. Here again is how we marked cylinder number 6. The connecting rods in some engines are marked right from the factory, but we made sure by marking them ourselves before disassembly. Then, turn the engine over on the engine stand and check for excess carbon buildup or a metal-like ridge at the top of each cylinder. If there's a noticeable ridge, it should be removed with a ridge reamer before further disassembly is attempted. A ridge reamer like the one shown here can usually be rented for only a few dollars, and they're not very hard to use. Set the ridge reamer in the cylinder to be reamed, and tighten the center bolt of the reamer to expand it to the same size as the cylinder wall. Tighten it until it is snug in the cylinder. Then with a large wrench, begin turning it clockwise. The reamer will automatically begin cutting the ridge out of the cylinder. Once the ridge seems to be visually cut out of the cylinder, double check the area for a ridge with your finger. If there seems to be some ridge left, repeat the same procedure with the tension on the reamer a little tighter. Ream the cylinder until the ridge is completely gone, but don't go any further down the cylinder than the depth of the ridge. Once the ridge is removed, loosen the tension on the reamer and remove it from the cylinder. Make sure you remove the ridge on each cylinder before removing any of the pistons. Trying to remove the pistons without removing the ridge from the cylinder walls can result in broken pistons or broken piston rings during removal. Next, rotate the crankshaft until the first 2 cylinders are at bottom dead center. Bottom dead center is when the throw of the crankshaft is at its lowest part of the rotation for the 2 pistons that are going to be removed. Remove the connecting rod cap nuts. Be sure to use a good socket and ratchet for this, as rod nuts are torqued on very tight. With the rod nuts removed, lightly tap the sides of the rod cap to loosen and remove them. If the bearing does not come off with the cap, carefully remove it from the crankshaft. To protect the crankshaft during piston removal, install a couple of short pieces of rubber hose over the rod bolts. Usually 3/8 hose works well for this. Then push the piston down and remove the piston and connecting rod from the block. Be sure to grab the piston as you are pushing it out of the engine block. Another way to remove the piston and connecting rod is to position the engine block upright and push the piston upward to remove it. For stubborn rod caps, you may have to lightly tap a small screwdriver into the splitting line of the rod cap. This will help loosen and ease the removal of the cap. Repeat this procedure until all of the rods and pistons are removed from the engine block. With all of the rods and pistons removed, we can begin removal of the crankshaft. First, mark the location of the main bearing caps in relationship to the front of the engine. Again, we use the center punch method to mark the bearing caps on our engine. Loosen the main bearing cap bolts. You'll most likely need a breaker bar and a good socket for removal of main bearing bolts. Remove the main bearing caps from the engine block. Rocking the caps back and forth using the bolts for leverage will usually remove the main caps easily. To remove the main thrust bearing cap, you may need to tap from side to side on the bearing cap with a small hammer. On our engine, the mid-position bearing was the main thrust bearing. It can be identified by the large shoulders built onto the sides of the bearing. As we remove the rear main bearing cap, notice the rear main crankshaft seal located just behind the rear main bearing. With all the bearing caps removed, remove the crankshaft from the engine block, being careful not to scratch any of the crankshaft journals. Also, be careful not to injure yourself or drop the crankshaft during removal, as crankshafts are quite heavy. Slide the main bearing shells out of the main caps and out of the main bearing saddles of the engine block. Remove the rear main bearing and the rear main bearing seal, and you're done.
As you can see, disassembly is pretty easy. But here's a couple of tips I like to use. If it's your first rebuild, you might want to lay out all your parts on a workbench following the order in which you disassembled them in. This will help minimize confusion when it comes time for reassembly. Also, a very important point I'd like to stress is to mark any bearing caps as we showed in the video. If even one of these caps gets put back together in the wrong spot or in the wrong direction, major engine damage will be the result. And lastly, whenever working on an engine in the garage, be sure to clean up any oil or antifreeze spills in the floor. A good way is to have some floor dry to put down on the spill immediately after it occurs. Just the spill alone is dangerous, but it could be even worse if you're carrying something heavy like a cylinder head or a crankshaft.
This section will deal with engine cleaning and block inspection. With the engine completely disassembled, it's time to begin cleaning and examination of the parts removed to determine what will be replaced or reinstalled in the engine. The tools you'll need during this section include a gasket scraper or putty knife, some parts cleaner and a large cleaning pan, a blade-type feeler gauge and a true straight edge, and an inside and outside micrometer set. Many of these tools can be rented, so check with your nearest automotive parts supplier before purchasing them. With a putty knife or gasket scraper, clean all of the gasket surfaces on the engine block. Thoroughly clean all the surfaces, as this is essential for good gasket sealing during reassembly. Next, we'll check the engine block for wear. First, wipe the excess oil from the cam bearings and inspect their condition. If you notice any wear, grooves, or pitting, the cam bearings should be replaced. Cam bearing replacement requires the use of a special cam bearing driver tool. We suggest having this procedure done by a qualified service technician or machine shop. Next, clean the inside of the cylinder walls. Any engine part to be measured for wear must be clean and free from dirt or oil for accurate measurements. A towel lightly doused in parts cleaner will work fine for this. Once clean, closely examine the appearance of the cylinder walls. Any bore that is deeply scratched or scored will require boring and the installation of oversized pistons. If the cylinder walls appear okay, no scratches or scoring apparent, they should be measured for wear. There are two alternatives for measuring cylinder wear. One method requires the use of an old piston ring and a feeler gauge. A more accurate method requires the use of a micrometer. The first method of measuring cylinder wear is the piston ring and feeler gauge method. First, we'll measure the cylinder taper. By taper, we're talking about the difference in wear between the top of the cylinder and the bottom of the cylinder. The area that will show the most wear is directly below the top of the cylinder, just under where you cut out the ridge earlier. On the other hand, the least amount of wear will be at the bottom of the cylinder. This gives you a cylinder with a funnel-like shape that's called taper. One way to measure the taper of the cylinders is by using an old piston ring and a feeler gauge. Although not the most accurate, it will give you an idea on whether or not you have to bore the engine oversized or if a simple glaze braking with a hone will suffice. First, remove an old ring from the top of one of the pistons and insert it in the first cylinder you're going to measure, just below the area where the ridge was removed. Square up the position of the ring in the cylinder with a piston that has all of the rings removed from it. With a feeler gauge, measure the gap at the end of the ring. Record each measurement for each cylinder on a sheet of paper. Then move the same piston ring to the bottom of the cylinder, squaring it up in the same manner as used in the top of that cylinder. Measure the ring end gap at this point. Take your time and measure each cylinder individually. Record your measurement on the same sheet of paper. The difference between these two measurements, when divided by 3, is the approximate taper of the cylinder. The taper of any cylinder should not exceed 8/1000ths of an inch. If the taper exceeds 8/1000ths, the wear is beyond the maximum allowance and the engine should be bored oversized and be fitted with new pistons. In our example, the top measurement and the bottom measurement had a difference of 30/1000ths. When divided by 3, our taper was approximately 10/1000ths and beyond the allowable maximum. Therefore, we chose to bore the block and fit it with new oversized pistons. Using the feeler gauge method to measure the cylinders will tell you how much taper they have, but it will not tell you how much wear or out of round a cylinder has. Although if the taper is within specification, generally the wear of the cylinder is also within specification. One of the most accurate ways to measure taper and at the same time measure the wear of the cylinders is by using an inside micrometer. Again, position the micrometer in the cylinder immediately below the ridge. Square it up in the cylinder and turn it until it lightly contacts the cylinder walls. Take the reading off the micrometer and record it on a sheet of paper. We recorded ours by listing them as top horizontal, mid horizontal, and bottom horizontal. Repeat this same procedure with the micrometer in a vertical position, measuring at various locations down the height of the cylinder. We also listed the vertical positions we measured in the same manner: top vertical, mid vertical, and bottom vertical for each particular cylinder. By subtracting the top measurement from the bottom measurement, we can tell how much taper the cylinder has. Even more importantly, we can match our measurements with the factory specifications out of an automotive service manual and determine how much wear there is on each cylinder. The amount of cylinder bore wear will determine how much work must be done to the engine to restore it to better than new condition. Just as our earlier measurement showed, our cylinders are worn beyond the specification and we must rebore the cylinders oversized. If your measurements show all the cylinders to be worn 8/1000ths of an inch or less, you may choose to break the glaze on each cylinder wall with an engine hone. But before we begin any remachining steps, we'll go one step further with the inspection and measuring procedures first. Another measurement to make on the engine block is to check the deck surfaces for warpage. Clean the deck surfaces with a scraper to remove any old gasket material or carbon buildup. Then wipe the surface clean with a towel lightly dampened in parts cleaner. Now you can check the block's surface for warpage. Place a true machine straight edge along the cylinder head surface of the engine block and then try to pass a 3/1000ths feeler gauge under it. Don't use a yardstick or piece of wood for this measurement, as it will not be accurate enough. If a 5/1000ths feeler gauge or larger fits under the straight edge anywhere on the block surface, the deck surfaces will require machining from a machine shop to bring them back within specification. In our case, we had over 6/1000ths clearance at one point in the block, so we decided to have the deck surfaces of the block machine true again. In most cases, this process is not necessary. Next, we'll inspect and measure piston to bore clearances. First, inspect the sides of the pistons for gouges or scoring. If the sides of the pistons are excessively scored, replacement can be determined without measuring. One way to measure piston to bore clearance is to measure the pistons with the micrometer and subtract these measurements from the bore measurements made earlier with an inside micrometer. Although more accurate, this does require the use of micrometers. Another way is by using feeler gauges. Remove the rings from the piston to be measured and insert it upside down in the cylinder it was removed from. Make sure the front side of the piston points towards the front side of the engine block. The front side of the piston can usually be determined by a dot or arrow on the top side of the piston, which points towards the front. With the piston in the block upside down, Find the maximum distance between the bore and the piston with a feeler gauge. Take several measurements at different positions in each cylinder. Record your readings for each cylinder on a sheet of paper. If any of these readings are beyond 25 thousandths of an inch, the clearance is beyond specification and the block must be bored and fitted with oversized pistons. Again, our engine showed piston to bore clearance beyond the general spec of 25 thousandths, which does coincide with our taper measurements made earlier.
All three methods of checking cylinder wear, measuring the taper, the out around, and the piston clearance, showed results that exceed the maximum allowable wear for our engine. Therefore, we chose to purchase a new set of oversized pistons and rings and to have a machine shop bore out the engine block to fit the pistons. Now, oversized pistons come in a variety of sizes depending on what engine and what size you need. They may be available in 10, 20, 30, 40, or 60 thousandths oversized for your application. They even go larger than that, but one of the most common sizes used during an engine rebuild is 30 thousandths. There are a couple considerations to keep in mind before ordering your new pistons. First, and probably the most important, is to have your engine block measured by the machine shop that's going to do the boring. They'll be able to tell you what size of pistons you need to order. Secondly, always order the pistons before having any machine work done on the block, because each piston will have to be fitted to a particular cylinder by the machinist. Now, if your block and pistons check out okay, you may choose to simply hone the engine block and install new piston rings on the old pistons, and that's what we'll demonstrate in the next two sections.
This section details piston cleaning, inspection, and engine honing. The only additional tools necessary in this section is a drill and a wire brush attachment. The first step in piston preparation is to clean and check the ring grooves. Remove the old piston rings from the pistons. Then soak the pistons in some carb or parts cleaner to help loosen the carbon that is built up in the ring grooves. Then, break an old ring in half and run it around in the grooves to remove any excess carbon. This is usually a little easier with the connecting rod clamped in a vise between a couple of small blocks of wood, with the piston skirts lightly resting on the top of the vise jaws. Another way is to use a ring groove cleaner. They're usually fairly inexpensive to purchase or rent and will do a better job of removing carbon buildup from the ring grooves. But be careful not to scratch or groove the ring lands on the outer surface of the piston. The only thing you want to remove is the excess carbon that may be built up in the ring grooves. With the ring grooves clean, reinstall an old ring, and with a feeler gauge, measure the clearance between the side of the ring and the groove it's resting in. Generally, this clearance should not exceed 4 thousandths of an inch. If it does, piston and ring replacement is necessary. With all the critical measurements made, finish cleaning any carbon that's built up on the top of the pistons with a putty knife or an old piston ring. A drill with a wire brush attachment also works well for this. Again, clean the rod and piston in parts washing solution. With the rod and piston clean, check for wrist pin to piston wear. Hold the piston in one hand, and with your other hand, try to twist the connecting rod back and forth. Also, try rocking the connecting rod sideways from its normal rotation. If any movement is felt, it usually means the piston is worn out where the wrist pin contacts it and will need replacement. For this reason, new pistons generally come packaged with new wrist pins. In most cases, the wrist pin is press fit into the connecting rod and is best changed by a machine shop. Although in some engines you may be able to change your own pistons and wrist pins if it came equipped with full floating pins. Full floating wrist pins actually move in both the piston and the connecting rod and are held in place with retaining clips on each end of the pin. Simply remove the retaining clips and push the wrist pin out one side of the piston. Install the new pistons in the connecting rods in the reverse order, making sure to put the piston on the connecting rod in the right direction. There is a right and a wrong way. This section covers proper engine glaze braking procedures. If your engine block and pistons pass the preceding general guidelines and you're going to install new rings on the old pistons, the next step is to break the glaze on the cylinder walls. To do this, you'll need a 1/2-inch drill, some light lubricating oil, and a glaze braking hone. A glaze braking hone does exactly what its name implies. It breaks the glaze left on the cylinders for normal engine operation and restores the cross-hatching pattern necessary for proper ring sealing. Chuck the hone up in the drill and set the tension on the stones so there is moderate drag on the hone when it is turned by the drill. Be sure the cylinders are clean and lubricate them and the stones on the hone with some light lubricating oil. Insert the hone and run it up and down in the cylinders until a uniform cross-hatching pattern shows in the cylinder. This usually takes between 2 and 5 minutes. Remove the hone from the cylinder while it is still slowly turning. Wipe out and check the pattern made by the glaze breaker. Preferably, the crosshatch pattern will be at 30-degree angles consistently up and down the entire cylinder bore. When you have broken the glaze on all of the cylinders, wipe the cylinders out with a clean towel and lightly lubricate them with some lubricating oil used when honing to prevent rust from forming on the inside of the cylinders. Cover the engine block with a large plastic bag to keep it clean from dust and outside contamination. The following section is crankshaft measuring and inspection. The specialty tool you'll need for accurate crankshaft measuring is a micrometer. If you do not have access to one, a nearby machine shop will mic the crankshaft for you. The first check to make when inspecting the crankshaft for wear is a visual inspection. Run your finger across all of the journals. If you can feel any grooves in any of the bearing journals, like these shown here, the crankshaft will have to be sent out for regrinding. Also look for scratches, cracks, or heavy blue marks on the bearing surfaces of the crankshaft. If any of these signs are apparent, it may need some welding and will have to be reground by a crankshaft regrinder or exchanged for one that has already been reground. If the bearing surfaces appear smooth, you'll need to measure them to determine their wear. Before measuring, make sure to wipe off any excess oil from the crank journals with a clean towel. One sign of wear we'll be checking for is out of round. Begin by measuring the diameter of each journal in several positions around it, but in the same plane. Record each measurement as you make it. If your measurements vary, the journal is out of round. Next, measure the bearing journals for taper. Measure each journal along its length and make a couple of measurements down its length in the same plane. Any difference found when making these measurements means the journal is tapered. Generally, the measurements for each journal should not show more than 1/1000th of an inch of taper or out of round. If your measurements exceed this specification, we recommend having the crankshaft reground undersize and purchasing undersized bearings for the installation. Make sure to measure both the rod journals and the main bearing journals of the crankshaft. Lastly, we'll measure the journal diameters. If you've recorded your readings from measuring taper and out of round, you can compare these readings with the journal diameters listed in an automotive service manual. If your measurements do not fall within the specifications from a service manual, the crankshaft will have to be sent out for regrinding. If your crankshaft does need regrinding, you can save time and probably save some money by ordering a crank kit rather than having it custom ground. A crank kit consists of a pre-ground crankshaft and the matching bearings included with it. You simply exchange your old crank when buying a kit, so there's no waiting to get yours back. That may be important if you're in a hurry to get things back together. Now we'll inspect the condition of our bearings. Inspecting the bearings can tell you quite a bit about the condition of your connecting rods and what kind of care the engine had in its previous life. Our crankshaft bearings showed wear all the way into the bronze-colored material of the bearing, as also was the case with our rod bearings. This not only is a sign of excessive wear, but a very likely chance of dirt contamination in the oil from the lack of regular oil and air filter changes. Once you've examined the bearings, you can remove them. A light push sideways should work to remove all of the main bearings except the main thrust bearing. The main thrust bearing is usually located in the middle or rear position of the engine. You'll probably need a screwdriver to loosen and remove the main thrust bearing from its position. Once removed, you'll see the side thrust surfaces built onto the bearing. These surfaces keep the crankshaft from walking forward or backwards in the engine block. Next, remove the rod bearings from the connecting rods. With the connecting rod cap removed, slide the bearings sideways to remove them from the cap and the rod.
Even if your bearings appear to have very little wear on them, I suggest replacing them with new ones anyhow. It's cheap insurance considering your engine is already apart this far. This section describes typical valve train inspection and disassembly. Disassembly of the valve train is necessary to complete our component inspection. One item I always recommend replacing is the camshaft. You might want to look into an aftermarket camshaft to help boost the performance or mileage of your engine once it's back in a vehicle. An aftermarket economy or performance camshaft like this one isn't much more expensive than a stock one and may prove to be a money-saving investment in the long run. Now let's take a look at the inspection.
We'll begin with the heart of the valve train, the camshaft. First, wipe any dirt or excess oil off the camshaft. Then closely inspect the cam lobes. If the lobes of the camshaft are worn or rounded off, replace it. Another sign of camshaft wear can be identified by close examination of the valve lifters. Inspect the bottom side of the lifter where it rides on the camshaft. If any of the lifters appear with a concave surface, they must be replaced. An easy way to tell is by placing the bottoms of two lifters together and attempting to rock them back and forth. Lifters that do not slightly rock should be replaced. The next connecting link in the valve train is the push rods. Closely inspect the ends of the push rods for wear. If they are a hollow type push rod, make sure they are not plugged. Then roll all of the push rods on a flat surface and watch for any wobble. Replace any that are bent, and don't try to straighten them as this can weaken a push rod, leaving it destined for early failure. We recommend replacing the push rods as a set whenever doing an engine rebuild. They're not that expensive and will help ensure peak performance and maximum longevity from your rebuild. Next, we'll look at inspecting the valves and the cylinder heads for wear. The tools you will need are a hammer, a valve spring compressor, a gasket scraper, a true straight edge, and a feeler gauge. First, clean any old gasket or carbon buildup from the surface of the cylinder heads with a gasket scraper. Then wipe the surface clean with a towel dampened in parts cleaner. Then check the surface of the cylinder heads for warpage. Hold a machine true straight edge against the surface of the cylinder heads, and just like when we measured the deck surface of the engine block, try to slide a 3/1000 feeler gauge under the straight edge at different spots along the surface of the cylinder head. You can slide a 5/1000 or larger feeler gauge under the straight edge at any point along the surface of the cylinder heads. They will require resurfacing to ensure a true flat surface for good gasket sealing. Now let's disassemble the cylinder heads. A wrap on top of each valve with a hammer will help loosen the valve locks. Then compress the valve spring with the valve spring compressor. There are different styles of spring compressors. We chose to use the C-clamp style as shown. With the valve spring compressed, you can reach in and remove the valve locks. Then loosen and remove the valve spring compressor from the cylinder head. Remove the valve spring retainer and remove the valve spring from the cylinder head. With the spring removed, you have access to the valve seal. Pull the valve seal off from the stem of the valve. Our engine had an umbrella style of valve seal like this. Another style of valve seal used on many engines is an O-ring type of valve seal. Either style can usually be easily removed with your hands. Move the valve to its mid-seat position and check for any side-to-side movement with the valve and the valve guide. If movement is noticed, the valve stem and possibly the valve guide are worn out and need replacing.
Due to the excessive wobble when we check the valve guides in our cylinder heads, we decided to send them into a machine shop for a valve job and resurfacing to get them back into shape. In most cases, I suggest taking the cylinder heads to a local machine shop and having them reconditioned there. If you were to try to purchase the equipment necessary to complete the valve job properly, you'd soon figure out that it's much more cost efficient to have it done by a professional. Now, let's continue with the inspection.
The last valve train parts we'll inspect for wear are the rocker arms. Clean and check the ends of the rocker arms where they ride on top of the valve. If you can feel any noticeable wear, replace them. If your rocker arms are like these, make sure to check for wear in the ball and seat area. but make sure you don't mix up which ball goes with each rocker arm. An easy way to keep them straight is to string the rockers and balls together with a piece of wire or an old hanger. This way you can clean and inspect them without mixing them up. When inspecting ours, we found excessive wear on the tips of the rocker arms and decided to replace them.
With everything inspected and measured, we'll wait for our parts to come back from the machine shop, and then we'll start reassembly.
In this chapter, we'll begin reassembly and crankshaft installation.
There are a few items that you'll need for reassembly that we haven't had to use yet. In this section, you'll need some oil-soluble lithium grease, a torque wrench, some hot soapy water for engine block cleaning, an oil squirt can or some engine assembly lube, and Plastigauge for checking bearing clearances. Probably the most important hint to remember when reassembling your engine is to take your time and don't be afraid to double check each step to be sure it's done right. Now, let's get started with reassembly.
When our engine block came back from the machine shop, this is what it looked like. It had already been hot tanked and cleaned up. The deck surfaces were machine true. The cylinders were bored, honed, and fitted for our new pistons and rings. If you don't have the machining and cleaning done by a machine shop, make sure to clean the engine inside and out with hot soapy water and rinse clean before starting reassembly. Then dry the bores with paper towels immediately after washing, and coat all of the machine surfaces with a light lubricating oil or a spray engine assembly lube like we're using. The first step in reassembly is to put the crankshaft back into the engine. Wipe out the main bearing saddles in the block with a clean, dry towel. If you ordered bearings for the crankshaft, make sure they are the correct size. The size of the bearing will be stamped right on the back side of the bearing itself. Then slide the bearings into place in the engine block. Don't touch the middle of the bearing surface when installing them. Slight pressure with your thumbs on the ends of the bearings should slide them in place. Be careful and make sure to align the notches in the bearing with the alignment notches in the engine block. Insert the bottom half of the bearings into the main bearing caps using your thumbs to press the bearings in place. Make sure to install the main thrust bearing in the correct bearing saddle. Remember, the main thrust bearing is the one with the side thrust surfaces. Then face the lip of the rear main seal inward towards the middle of the engine and press the top half of the rear main seal in place in the engine block. Also, press the bottom half of the rear main seal in the rear main bearing cap. With all the bearings dry and the rear main seal in place, carefully set the crankshaft straight down into the engine. Do not lubricate the bearings yet. The reason for not lubricating the bearings is because they must be dry to check the oil clearance between the crankshaft and the bearings with Plastigauge. Plastigauge is a very thin, round piece of plastic that when crushed on the bearing surfaces will tell you roughly how much oil clearance you have between the bearing and the crankshaft. Carefully place a small piece of Plastigauge on each journal of the crankshaft where the bearing meets the crank. Then, place the main caps on the engine in the correct order and direction. A light tap on the bearing cap will help seat it in place. Lightly oil the threads of the main cap bolts and then snug them up with a wrench. Make sure not to turn the crankshaft while you are Plastigauging. This will smear the Plastigauge and ruin the readings. Then begin torquing the main bolts in increments of 20 to 25 foot-pounds until all of the main bolts are torqued down to the factory specification. When all of the main cap bolts have been torqued down, loosen them with a breaker bar. Carefully remove the main bearing caps. You'll notice the Plastigauge on the crank or bearing has now been crushed flat. If your crank journals are true, the Plastigauge should be the same size its entire length. Match the width of the Plastigauge with the scale on the outside of the package it came in. Generally, 2 to 3 thousandths of an inch is an acceptable clearance. Although, consult a published service manual for the correct specification on your particular engine. Once you've checked all of the journals, carefully clean the Plastigauge off from the crankshaft and the main bearings with your fingernail and lightly polish the journal with a soft, clean towel. Then remove the crankshaft from the engine block. Making sure you have clean hands, spread a very light film of oil-soluble lithium grease on the surface of the bearings and on the sides of the main thrust bearing. This will provide a protective film of lubrication for the bearings and the crankshaft during the rest of assembly and during initial startup of the engine. Be sure to lubricate the camshaft bearings at the same time, as they are much more difficult to reach once the crankshaft is installed. With a good grip on it, carefully lower the crankshaft straight down into the bearings. Then lubricate the lower bearing halves with the same lithium grease, being careful not to get any grease on the bottom of the bearing cap where it contacts the engine block. Make sure you install the right cap on the right bearing journal with the arrow on the cap facing the right direction. Again, you may need to lightly tap each main cap to seat it in place while you're installing the bolts. Then begin torquing the main bearing cap bolts with a torque wrench. Start at one end of the crankshaft and torque all of the bolts to a low setting, like 20 foot-pounds. Gradually increase the torque value each time by 10 or 20-pound increments. We torqued ours in 20-pound increments, the next one being 40 foot-pounds, then at 60 foot-pounds, then at 80 foot-pounds, and finally at 100 foot-pounds, our final torque setting. Spin the crankshaft by hand after each torque setting is completed. It should spin easily with no binding.
When checking bearing clearances with plastic gauge, there are a few different colors to choose from. Now each color represents a different range of clearances. Green will check clearances from 1 to 3 thousandths of an inch. Red will check clearances from 2 to 6 thousandths of an inch. And blue will check clearances between 4 and 9 thousandths of an inch. In most cases, you'll want to use a green plastic gauge. Now during reassembly, you'll need to know several different torque values or sequences to ensure proper performance of your engine once completed. These specifications can be found in just about any automotive service manual under the engine tightening specifications section. Now, let's move on with reassembly.
This section will cover ring and piston installation. The specialty tools needed in this section include a piston ring expander, snap ring pliers, a wooden handle hammer, and a piston ring compressor. Before assembling the rings on the pistons, make sure you insert them into each cylinder and measure the ring end gap. This will ensure that you have the right piston rings for your engine. Generally, 10 to 20 thousandths ring end gap is acceptable, but double check an automotive service manual for the correct specification on your engine. First, place the expander ring in the bottom ring groove. Then install a bottom scraper ring over the expander ring. Be careful not to scratch the side of the piston with the end of the scraper ring. Install the top scraper ring around the expander ring. Again, be careful not to scratch the side of the piston with the end of the scraper ring. Space the end gaps of the oil scraper rings 180 degrees apart from each other and 90 degrees away from the end of the expander ring. Next, we'll install the compression rings. Using a ring expander, expand the second compression ring and carefully place it on the second groove of the piston. Installing compression rings are a little different than oil rings because they have to be installed with the correct side up. To identify which side is up, the top side of the compression ring is usually marked with a dot or an indentation near the ring end gap. Refer to the instructions included with your new piston rings as to how yours are marked and follow them closely. Then install the top compression ring, again with the marking on the ring pointed upwards. Because we had full floating wrist pins in our engine, we assembled the pistons to the connecting rods. If yours is like this, make sure you get the piston on the rod in the right direction, and with the snap ring pliers, position the pin retaining snap rings in the piston. As we stated earlier, the tops of the pistons are marked with a notch or arrow to tell you which side of the piston goes towards the front of the engine. Next, we'll install the rod bearings in the bottom sides of the connecting rods. Install the rod bearings using the same manner as when we installed the main bearings. Make sure to position the bearings with the alignment pin corresponding to the alignment boss on the connecting rod. With all of the rods and pistons ready to go in, position the crankshaft so the journal of the first two pistons to be installed is at bottom dead center. Then spray a light lubricating oil into the cylinders to be installed and wipe them out with a lint-free cloth. Once clean, lubricate the inside of the cylinder walls with a thin coat of engine oil. A small oil squirt can works well for this. Slide the same two pieces of rubber hose used during disassembly over the rod bolts to protect the crankshaft during piston installation. Position the piston in the cylinder with the arrow or notch towards the front of the engine. The ring end gaps on the piston should be positioned in specific spots. Consult an automotive service manual for the specific ring end gap positioning for your engine. With the oil squirt can, lubricate the inside of the ring compressor with a light coat of engine oil. Position the compressor down over the piston and tighten the ring compressor snugly over the rings. Tap the top of the piston into the bore with the wooden end of your hammer just until the piston is at the top of the bore. Then set the ring compressor aside and with your free hand reach around the bottom side of the engine and guide the bottom of the connecting rod over the crankshaft journal while you finish tapping the piston the rest of the way into the bore. When it's all the way in, remove the small rubber hoses from the connecting rod bolts. Move to the next cylinder that shares the same crankshaft journal as the first one installed and repeat the same installation procedure. If the piston stops abruptly when you're tapping it down into the cylinder, do not force it into the cylinder. Most likely a ring has slipped out of the ring compressor and serious damage to the piston or rings could result if force is applied to install it. Instead, loosen the ring compressor, reposition it, and start over. With the first two pistons and rods in and the bearings dry, we'll plastic gauge the rod bearing to crankshaft oil clearance, similar to when we check the oil clearance of the main bearings. Then position the rod caps in place. Make sure they are facing the right direction on the crankshaft. One way to make sure is to line up the bearing tabs on the same side of the connecting rod. With both caps in place, install and lightly tighten the rod bolt nuts, and make sure you do not turn the crankshaft whenever plastic gauge is installed in the bearings. Torque the rod bolts to the specified torque rating. Again, torque rod bolts in increments of 15 or 20 foot-pounds, ending up at the final torque setting for your engine. Then loosen and remove the rod bolt nuts. Remove the rod caps. You may need to tap lightly on the sides of the rod caps to remove them. Then measure the flattened plastic gauge with the scale on the outside of the package. Generally, 1 to 2 thousandths is an acceptable clearance for connecting rod bearings, but check the actual specifications for your particular engine. Once measured, lightly scrape the plastic gauge off from the crank and the bearings with your fingernail, and polish any remaining plastic gauge off with a soft towel. Now we'll lubricate the rod bearings for final installation. Slide the protective hoses over the rod bolts and slide the pistons up in the cylinders far enough to lubricate the bearings. Be careful not to slide any of the piston rings out of the bore or you'll have to reinstall them with the ring compressor. Make sure to lubricate both the crank journal and the bearings with a light coat of lithium grease. Tap the piston back into the bore until the connecting rod contacts the crankshaft. Remove the rubber hoses and reinstall the rod caps, making sure they are installed in the right connecting rod and facing in the right direction. Lubricate and reinstall the rod nuts and tighten them to the correct torque setting using the same manner as used earlier. Again, end up on the final torque setting as specified in a service manual. Then rotate the crankshaft a few times to check for any binding and stop when the next rod journal is in place for the installation of the next two pistons. Repeat the procedures just used on the first two pistons until all of the pistons are installed in the engine. This section will show correct oil pump installation and oil pan installation. Next, we'll prepare the new oil pump for installation. But first, we must remove the oil pump drive shaft and the oil pump pickup tube and screen assembly from the old pump. To remove the pickup tube on our pump, we had to remove the two mounting bolts. Some pickup tubes must be driven out with a hammer and a block of wood and reinstalled in the same manner. Thoroughly clean the pickup tube before reassembly, then reinstall it in a new gasket on the oil pump. Make sure you install the oil pump drive shaft in the new pump before bolting it back onto the engine. Then install the new oil pump and gasket, if so equipped, onto the engine block and tighten the mounting bolts securely. Next, we installed the oil pan. Put a light coat of gasket sealer on the bottom gasket surface of the engine block, mainly to hold the gaskets in place. With the gaskets in place, install the old pan on the engine. Start all the bolts into threads before tightening any of them. Tighten the bolts on the oil pan by starting in the middle of the engine on both sides and work towards each end. Oil pan bolts do not require torquing. Just tighten them good and snug with a ratchet wrench. Next, we'll install the cylinder heads on the engine. This is how our heads looked like when they came back from reconditioning. The sealing surfaces were machined flat, the valves were ground or replaced, and new valve guides were installed. We also had new valve seals and new valve springs installed. Normally, new springs are not necessary unless the camshaft is being changed to a higher performance camshaft. If you choose to install your own new valve seals, here's how. Simply install the new seal on the stem of the valve. In this case, we're installing an O-ring type of seal. Then position the valve spring and retainer over the valve. Position the valve spring compressor over the spring and compress the spring. Then carefully insert the valve locks in between the valve stem and valve spring retainer. With the locks in position, carefully release the pressure on the valve spring compressor, and that's it. Repeat this same procedure on the remaining springs until all of the new valve seals are in place. Now, place the new cylinder head gaskets on the engine block. Make sure the markings on the gasket point up and all of the holes in the gasket line up with the holes in the engine block. Carefully set the cylinder heads on the engine block, aligning the dowel pins on each side with the dowel pin holes in the cylinder heads. You may need to tap lightly on the cylinder head with the rubber mallet to get the heads to set in place. Begin threading the cylinder head bolts in place. Lightly lubricate the threads of the head bolts with oil or never seize before installing them. Only tighten them finger tight for now. Locate the head bolt tightening sequence from an automotive manual. This sequence must be followed during the torquing of cylinder heads to ensure proper sealing of the head gasket between the head and the engine block. To ease the process of torquing head bolts, label the top of each bolt with its respective number in the torquing sequence. Complete the entire torque sequence by first starting at a low torque setting, then increase the setting in 3 or 4 steps until you reach the final torque setting. Our final specification was 90 to 95 foot-pounds of torque. Now we'll begin engine painting. With the cylinder heads in place, we decided to paint the engine. Before painting, tape off or spread a light coat of grease over the gasket surfaces and any other parts of the block that you do not want paint on. Also, be sure the block is clean and free from oil on the surfaces to be painted. Install some old spark plugs in the spark plug holes to keep paint out of the cylinders. With a good quality engine paint, paint the engine in several light coats. We also set the timing cover in place to protect the camshaft area of the engine from getting painted and to paint the cover at the same time. Instead of installing the original block drain plugs, we chose to install block drain fittings for ease of draining the block in the future. Then install the motor mount brackets and the motor mounts back on the engine block. Next, we reinstalled the oil filter mount on the engine. Put the gasket in place dry and tighten the mounting bolts securely. In this section, we'll cover camshaft and timing chain installation. The items you'll need include camshaft lube and red Loctite. To increase the performance of our engine, we purchased an aftermarket camshaft kit, complete with new camshaft, lifters, and cam lube. Before installing the new cam and lifters, make sure to thoroughly coat the bottoms of the lifters and the lobes of the camshaft with camshaft assembly lube. It usually comes with a new camshaft kit or can be purchased separately if needed. With all of the camshaft lobes lubricated, temporarily install the cam gear onto the front of the camshaft. This will give you more leverage for camshaft installation. Then carefully begin sliding the camshaft into the engine. Take your time when installing the cam so you don't hit and damage any of the cam bearings inside of the engine block. Grasp the cam gear firmly to help guide the last bit of the cam into the engine. With the cam installed, remove the gear from the camshaft. In our case, we then installed the camshaft cover plate. Be sure to tighten the bolts securely and lubricate both the inside and the outside of the cam plate or engine block before installing the cam gear. To install the crank gear, put a light coat of oil or assembly lube on the snout of the crankshaft to help the gear slide on easier. Slide the crankshaft gear onto the snout of the crankshaft. Make sure to line up the key in the crankshaft with the keyway in the crank gear. You may need to tap the gear onto the front of the crank with a hammer and a small block of wood. If the gear slides right on, an extra tap will help ensure the gear is all the way onto the crankshaft. Turn the crankshaft until the small dot or timing mark on the gear is in the correct position for timing alignment. As with most engines, ours had to be pointed straight up. With the camshaft gear in place, turn the cam until the mark on the gear is at the correct location for proper cam timing. The manual specified the timing mark on the cam gear of our engine should be at the lower side of the gear, in direct alignment with the mark on the crank gear. With the gears aligned, lubricate the timing chain with a little motor oil to protect it during initial startup. Remove the top gear from the camshaft and place the timing chain around it. Work the chain around the crankshaft gear and slide the top gear onto the nose of the cam. Again, make sure you align the mark on the top gear with the mark on the crankshaft gear. Put a small amount of red Loctite on the threads of the cam bolt and install the fuel pump eccentric and cam bolt onto the nose of the camshaft. Torque the cam bolt to factory specifications. Before installing the timing chain cover on the front of the engine, carefully drive out the old crankshaft seal with a hammer and punch. Tap the new seal in place. Be careful when installing the new seal so you don't bend or damage it during installation. You may want to use a small block of wood to help drive the new seal into the cover. Then slide the crankshaft oil slinger onto the nose of the crankshaft. Your engine may or may not have one of these. Then put the timing chain cover gasket in place and seal the corners and the bottom where the timing cover and oil pan meet with a small bead of silicone sealer. Put the cover in place and start all the cover bolts by hand. And then tighten them with a socket wrench and socket. Don't forget to install and tighten the bolts that go through the oil pan into the timing chain cover. Next, we'll repair and install the harmonic balancer. Our engine had a two-piece harmonic balancer and spacer assembly. Before installing the spacer, we noticed the sealing surface was severely grooved from wear of the front seal. This can be repaired without machining with the sleeve and seal repair kit. They're inexpensive and will repair the sealing surface quickly and easily. Here's how. Spread a thin layer of sealer contained in the kit around the neck of the surface to be repaired. With a rubber mallet and a block of wood, carefully drive the repair sleeve onto the crankshaft spacer until it is all the way down over the repair surface. Then lightly oil the outer sealing surface of the repair sleeve and slide the spacer in place on the snout of the crankshaft. Before installing the harmonic balancer, make sure the woodruff key is in place. Tap it in lightly with a hammer if necessary. Slide the harmonic balancer onto the crankshaft and start it onto the crankshaft with a few taps from a rubber mallet. Start the center bolt for the balancer by hand and finish tightening it with a socket wrench. Now we'll go back to the top side of the motor and install the valve lifters. First, lubricate the lifter bores in the block with a light coat of engine oil. With a liberal amount of camshaft assembly lube on the base and sides of the lifters, install each lifter all the way into the lifter bore and push it down until it rests against the lobe of the camshaft. Continue lubing and installing the new lifters until all of them are in place. Make sure all the lifters move freely up and down in the lifter bores when installing them. This section will cover exhaust manifold and clutch installation.
If your vehicle is equipped with an automatic transmission, parts of the next section that we're going to show will be a bit different. Now, many times the transmission can be connected to the engine and both drop back into the car at the same time. In our case, due to the crossmember location, we couldn't do it that way. Now, if you do install the transmission and the engine at the same time, make sure you plug the rear yoke of the transmission, because if you don't, you'll end up with a pretty large spill on the floor. Now let's get back to reassembly.
Because we rebuilt an engine from a car with a standard transmission, the only specialty tool used for proper clutch installation in this section is a clutch alignment tool. Now, install the exhaust manifolds. If your exhaust manifolds are pitted or corroded, or exhaust manifold gaskets are not available for your engine, a light bead of red high-temperature silicone on the manifold surfaces will help seal them to the cylinder heads. Then place the manifolds up to the cylinder heads and start all of the manifold bolts by hand. Replace any exhaust manifold bolts that seem to be weak or corroded and tighten them evenly with a socket wrench. With the engine off the engine stand, we installed a new pilot bushing in the crankshaft. Then, place the flywheel shield on the engine block and position the flywheel on the crankshaft, aligning the marks we made during disassembly. While our engine parts were out for machining, we also had our flywheel resurfaced. This will provide the best adhesion and longest life from our new clutch. Place a small amount of red Loctite thread locking compound on the threads of the flywheel bolts and start them in the crankshaft by hand. Again, tighten the bolts with a torque wrench in a star pattern, completing the pattern in increments of 20 foot-pounds until the final torque setting is reached. Next, we'll install the clutch and pressure plate. We decided to purchase a new performance clutch versus a stock replacement clutch for longer life and better performance. Position the pressure plate on the flywheel and start a couple of the top bolts to hold the pressure plate in place. Then slide the clutch disc in between the flywheel and the pressure plate and start the remaining bolts by hand. Make sure to position the correct side of the clutch disc against the flywheel. The flywheel side of the clutch disc is usually marked with a sticker or stamped right onto the disc itself. Now align the clutch with the flywheel before tightening the pressure plate bolts. This can be done by using an old input shaft from a transmission or by using a clutch alignment tool. With the clutch plate aligned with the flywheel, begin tightening the pressure plate bolts a little at a time. Tighten each bolt about one full turn and move on to the next one until they are all evenly snug against the flywheel. This will prevent clutch warpage and uneven clutch pressure. Finish tightening the pressure plate bolts with a torque wrench to their final torque setting as specified in an automotive service manual. Then remove the clutch alignment tool from the clutch assembly. Install the bell housing on the engine and start all the bolts by hand. Tighten the bell housing bolts securely with the socket wrench. We recommend installing a new clutch release bearing whenever installing a new clutch. It can save a lot of extra work at a later date. Insert the bearing inside the bell housing and position it on the clutch release fork. The last component we're going to install before hoisting the engine into the car is the starter. Then attach the positive battery cable to the starter. It's a little easier with the engine still out of the car. And now's a good time to reattach any routing brackets to the bottom side of the engine block while they're still readily accessible. This section will deal with reinstalling the engine.
Now, the best piece of advice I can give anyone for reinstalling their engine is to take your time and be patient. It might not make the installation go faster, but it'll sure make it go easier and a lot less frustrating. Let's take a look.
First, hook the engine chain to the engine, and with the help from a friend, begin hoisting the engine back into the engine compartment. Take your time and make sure you don't bend any linkages or disturb any wires or hoses left in the engine compartment. Carefully align the motor mounts while lowering the engine and slide the motor mount bolts through when they're aligned. Tighten the motor mount bolts with a socket and hold the nut from turning on the other side with another wrench. When the motor mount bolts are in and tight, you can remove the engine chain and move the engine hoist out of your way. Now you can begin the final reassembly steps on the way to your new engine. Next, go underneath the car and reinstall the driveline. This will relieve some of the pressure from the weight of the engine off from the motor mounts. First, slide the transmission into the bell housing. Make sure the transmission is all the way up against the bell housing before installing and tightening any of the bolts. Then start all of the transmission mounting bolts into the bell housing by hand and finish by tightening them securely with a large wrench. Reinstall the transmission crossmember and attach the rear transmission mount. You'll most likely need to use a floor jack to raise the transmission into place. Remove the tape around the rear U-joint of the drive shaft and reinstall the drive shaft into the car. Make sure to align the chalk marks made on the drive shaft and rear yoke during disassembly. Then reinstall the rear U-bolts and tighten the nuts securely. Reconnect any shifter linkages, the speedometer cable, and anything else that was originally disconnected from the transmission. Reconnect the clutch linkage, and adjust the clutch free play. Consult an automotive service manual for how much free play is correct on your vehicle. With everything connected underneath the car, we started back up front by installing the lower pulley on the harmonic balancer. Next, put a light coat of silicone sealer on the water pump mounting areas, and with the gasket already mounted to the water pump, position the water pump on the engine block. Install and tighten the water pump mounting bolts. Now spread a thin coat of sealer around the fuel pump mounting area, and position the fuel pump mounting gasket on the engine block. Put a liberal amount of light grease on the arm of the fuel pump, and insert the pump and start the bolts by hand. If the bolts do not start easily, don't force the pump into position or pull it into position with the bolts. To ease installation, crank the engine over with a socket wrench to move the position of the camshaft or fuel pump eccentric. Then reposition the fuel pump and restart the mounting bolts. Once repositioned correctly, tighten the bolts on the pump. Then connect the fuel lines up to the fuel pump. To ensure a good seal, place a small amount of Teflon thread sealing tape on the fittings of any steel lines that go into the fuel pump. Then reinstall the radiator into the engine compartment, and install and tighten any radiator mounting brackets as necessary. Install the lower radiator hose, and tighten the clamps on the radiator and water pump ends of the hose. Reinstall the water pump pulley and install the fan back onto the engine. Tighten the fan bolts securely. Reinstall the timing tab onto the timing chain cover and snug the bolts lightly. Don't over-tighten these bolts as you may strip out the threads in the cover. Position the alternator mounting brackets and reinstall the alternator on the engine, but only loosely install the mounting bolts at this time. Route your belts around the appropriate pulleys and pull them tight with your hand or use a wooden pry bar if you can't get enough tension on the belts by hand. With the belt tension tight, tighten any adjustment bolts and pivot bolts of the components being installed. Next, we'll install the intake manifold. First, reinstall the oil splash pan back into the lifter galley. We chose to replace our factory intake manifold with an aftermarket aluminum manifold for added performance and throttle response. Set the new manifold next to the old one and change any fittings, sensors, carburetor mounting studs, etc. from the old manifold over to the new one. Be sure to use thread sealing tape on any vacuum or water passage fittings in the intake manifold. Then put a light bead of silicone sealer around the water passages on the intake manifold gaskets. Position the manifold gaskets on the engine, making sure all the water passages, bolt holes, and ports line up. Place a small dab of silicone sealer in the four corners where the cylinder heads and block meet. Position the rear manifold gasket in place, and again place a small dab of sealer where the gaskets meet. Then position the front manifold gasket on the front of the block and seal the corners with silicone. Now you're ready to install the intake manifold. Slowly lower the manifold straight down onto the gaskets. Be careful not to disturb the manifold gaskets when lowering the manifold. Install all of the manifold bolts by hand until they're finger tight. Locate the manifold tightening sequence from a service manual before tightening any of the manifold bolts. Following the tightening sequence, snug all the manifold bolts first, then torque them in 10-pound increments until you reach the final torque specification. Apply a light coat of sealer to the thermostat gasket, and install the thermostat housing, thermostat, and the gasket to the intake manifold, and start the mounting bolts in place by hand while holding the housing in place. Tighten the mounting bolts with a socket wrench to finish the installation. Now, let's complete the final hookup procedures and start the engine. The specialty items you'll need during initial startup include a timing light, an oil pressure gauge and a tachometer if your vehicle isn't equipped with one, a half-inch drill, an oil pump priming shaft, and possibly a distributor wrench. Next, reinstall the heater hoses. We suggest replacing them now during reassembly. It'll make your engine look nicer and prevent an unexpected failure later on. Install the heater hose over the fittings, position the new clamps, and tighten them securely. We also installed new radiator hoses and clamps to make sure we didn't experience any cooling system failures with our new engine. Next, install the push rods, making sure they set correctly into the lifters. Then position the oil baffles in place on the cylinder heads. Your engine may or may not have these. Put a light coat of lithium grease on the tips of the rocker arms and also on the ball socket on the other side of the rocker arm. Position the rocker arm assemblies on the cylinder heads. Take your time and make sure the shaft is positioned correctly. There is a right and a wrong way. Also, make sure all of the push rods are aligned properly in the respective rocker arm. Install the rocker arm shaft bolts and tighten them until they're hand tight. When tightening the shafts, alternate between the bolts and the shaft until it sits snug against the cylinder head. Then tighten the rocker shaft bolts in 10-pound increments until they are all torqued to the final specification. Now place the carb base gasket on the intake manifold and place the carburetor on the engine. We chose to install a new performance carburetor to top off our engine rebuild. Install the carburetor mounting nuts and tighten them evenly, but don't over-tighten them or you could crack the base of the carburetor. Install the fuel line to the carburetor and tighten it securely. Reconnect any throttle or kickdown linkages up to the carburetor. Be sure to reconnect the throttle return spring to the linkage. Reconnect any vacuum fittings and hoses that are not already connected to the intake manifold. Now, crank the engine over until the intake valve on cylinder number 1 closes. The first time top dead center comes around after that is when the number 1 cylinder fires. Try to stop the engine 5 or 10 degrees before top dead center. Now install the new valve cover gasket on the valve covers. Place the valve covers on the engine. Start all the bolts by hand before tightening any of them. Snug the valve cover bolts evenly, but be careful not to over-tighten these bolts, as damage to the new gaskets will result. Install the new oil filter and tighten it as per specified on the side of the filter. We took this opportunity to pour the new engine oil right down the distributor hole of the intake manifold. Use the same brand of oil you'll normally use in the future. We recommend using 10W30 viscosity oil or greater for initial break-in. Next, we installed an oil pressure gauge in the oil pressure sending unit spot on the top of the oil filter. The gauge will tell us if we have oil pressure when we prime the oil pump. To prime the oil pump, you'll need a 1/2 inch drill and an oil pump prime shaft. Instead of using a commercially produced priming shaft, we made our own primer out of an old distributor. We removed the bottom gear and the parts on the inside of the distributor so we could turn the shaft freely with a drill. Set the shaft down into the distributor hole until it contacts the top of the oil pump drive. Spin the shaft in the same direction as distributor rotation until sufficient oil pressure shows on the gauge. Continue spinning the drill for about 1 minute after you see oil pressure on the gauge to allow adequate oiling of the lower end of the engine. Now we can install the distributor. Align the vacuum advance in the same direction it was originally and point the rotor at the number 1 spot of the distributor cap. Install the distributor hold down with the bolt loose enough to allow movement of the distributor for ignition timing adjustment. Reinstall the ignition coil and bracket on the engine. Reroute and reconnect the positive and negative wires on the coil, and connect any remaining wires to the sending units as necessary. Reconnect the vacuum advance and any remaining vacuum hoses that have not been connected. Gap, install, and tighten the spark plugs. Then reinstall the distributor cap and spark plug wires. Make sure to route the wires so they do not lay on exhaust manifolds, and so each wire is routed to the correct cylinder. Connect the positive battery cable from the starter to the solenoid, and then connect the positive cable from the battery to the solenoid. Connect the negative cable to the battery, and the other end of the negative cable to a good engine ground, often located near the alternator. Fill the radiator with a 50-50 blend of water and antifreeze. We're now ready to start the engine for the very first time. Crank the engine and pump the accelerator a few times. You may need to slightly move the distributor to get it to start. As soon as the engine starts, make sure you have oil pressure and raise the idle to approximately 2,000 RPMs right away. This will help break in the new cam and seat the new piston rings. Add coolant as necessary and check underneath the vehicle for leaks. Make sure to check the fuel lines around the carburetor for leaks. After the engine has been run at 2,000 RPMs for at least 1/2 hour, lower the idle, and recheck the ignition timing. Reset it if necessary, and tighten the clamp on the distributor. Reinstall the air cleaner. We chose to install a chrome air cleaner to match the valve covers we installed on the engine. With the help of a friend, bolt the hood back onto the hood hinges. Align the marks made during disassembly, and you should be real close on hood alignment. Close the hood slowly for the first time and double check the alignment. Drive the car moderately for the first couple hundred miles at varying throttle positions, both accelerating and decelerating. Change the oil and filter somewhere within the first 1,000 miles to clean out any assembly lube that is still in the engine.
There's a couple safety hints I want to remind you about during initial startup. First, make sure you have a damp cloth and a halon fire extinguisher handy in case of a carburetor fire. It's pretty common to have a car backfire in initial startup due to the ignition timing not being quite right yet. For that same reason, never lean over the carburetor when you're first starting the engine. I'm sure you'll be successful with your engine rebuild if you follow the steps outlined in this tape and use the assistance of an automotive repair manual. And the procedures shown in this tape are general in nature. I recommend getting a repair or rebuild manual like one of these to help you with the specific details on your engine. I'm Scott Cusey for Car Care Seminar. Thanks for choosing our tape. And before you tackle your next repair, check to see if there's a Car Care Seminar tape to help you along. Till then, buckle up and drive safely. I'll see you next time. If you have any comments, suggestions, or topics you'd like to see covered, please drop us a line at Car Care Seminar, 5520 North Highway 169, New Hope, Minnesota 55428.